So the goal for Lustre HA is quite simple. It's really to detect failures, provide an architecture to deal with any levels of failures, to provide continued access to data, or really just limit the I/O interruption to applications during a failure event. And one of the architecture basics of Lustre HA is to provide redundant components of all levels of Lustre, from the hardware up to certain components, to make it redundant in the software side as well. At a minimum, where do we start? We start at the data protection layer to protect against multiple drive failures. And one of the basic solutions is design a data protection layer around RAID 6 for obvious reasons, do parity drives, 8 data drives. And then the other thing is to avoid these rare cases that we always say will never happen, is multiple drive failures within the same data protection layer. So you use the use of hot sparing, as well as rebuild rates are also quite critical in this area as well. Depending on the default rebuild rate for a storage solution running Lustre, having a slow rebuild rate could increase your chances of another drive failure within the same data protection layer. So you have to balance the rebuild rate as well as your front-end OST performance to really provide continuous data access without minimizing application performance. So also adjusting rebuilds on the fly is quite critical during the aspect of a drive failure, especially when you have a large amount of drive and a large amount of capacity that you're trying to provide a file system for running applications for increased performance. The other aspect of it is to provide high availability domains. And the minimum aspect to provide high availability domains is pairing 2 Lustre servers in a HA partner pair. And this goes for the fact of OSS partner pairs as well as for MDT partner pairs as well. So the aspect of building a HA partner pair is to provide redundancy on the heartbeat side. Now, one can look at redundant heartbeat connections and provide 2 Ethernet connections, and one is primary, one is secondary. But to really increase maybe the heartbeat connectivity is maybe leverage an internal heartbeat within a storage chassis that mimics a NIC, and you probably could architect a virtual NIC to really increase the reliability of a heartbeat connection. And then your secondary heartbeat could be an external network like an Ethernet type functionality. The other thing as well is you want to have dual paths to the drives as redundancy on the SAS side as well. So then both partner pairs sees all the drives and could fail over to one another in the event of an HA event. And then the other aspect of it is for the fabric side, you want to have redundancy on the fabric side. So you want to actually provide one side of the HA domain to go to one fabric switch and the other HA partner pair to go to the second fabric switch, because if they're all connected to one core switch or one leaf switch, then your HA configuration is still your single point of failure for the fabric side as well. On an HA event detection, you want to make sure that when you detect a failure or a problematic portion of an HA, that it's actually an HA event and nothing just a lot of load on one particular OSS or an server, because a failover in all essence is costly, meaning it's costly to doing a failover as well as costly to doing recovery on those targets, because an application, depending on how large your cluster is, the recovery could be the longest piece of bringing a resource back up to continue application performance. So you want to look at detection on the fabric side. You want to look at detections of errors on SAS, on the heartbeat if it's compromised, on if there's any software issues that causes an HA event, or any type of a hardware failure that causes an HA event. You really want to have rules in place and timeouts to really decide when an HA event actually occurs to do that automatic failover. So the other thing as well is that when you look at a failover event, you want to ensure that the problem node is somehow removed from the equation. So one solution could be use Stoneth or shoot the other node in the head. And any question that a partner node is causing problems in the HA pair, you want to not just guess that the HA node is failing or say, hey, we'll leave that node up and fail over the resources, because leaving a problematic node up can cause further issues in the overall HA pair. But to use Stoneth really eliminates that problem node or any question of that node from the equation, and then do the failover of those resources, or remove any type of additional issues that can occur during an HA event. And then once the partner node powers off the unhealthy node, the resources will automatically fail over based on the policies that is driven by the HA functionality as well. And then one of the things that I mentioned earlier is that a failover could be the shortest aspect for bringing back resources, but the longest thing could be the imperative recovery for bringing that OST back available to the client side as well. And that also depends on how large the cluster and how many clients need to replay to really reconnect to those to that target, and that also applies to the MDT as well as the OST as well. So you really want to make sure that when an HA event occurs, you're actually doing the right thing to do in a failover, because the recovery can be the most costly aspect of a failover. On failback, one notion could be you could do an automatic failback once those resources are available, or another aspect is that failback is manual. And one of the things that recommendation is always do failback manually, because it gives the administrator the chance to repair anything on that node that causes the HA event. It could be because there was an L bug, there was a SAS HBA that is causing issues, there is a SAS link that does multiple retries from that node, there is an expander that is causing issues, any issue. And it also avoids the costly aspect of doing another failover to the partner node to restore the configuration back to the original design, is that if a resource is up and running and recovery is complete, why have the other costly factor doing another failover during an event an application is running? And then the other aspect of it, to minimize the impact of failure, you really want to have a modular approach to your storage architecture, that a failover event only occurs at a small percentage of your overall Lustre storage solution, so to reduce impact of your overall applications that are running on the cluster side. I mentioned this a little bit on the fabric connectivity as well. You want to actually have redundancy on the leaf side or on the overall fabric side, that half of your HA partner pair is on one fabric switch, the other half is on a separate fabric switch. So in the event of a switch failure, you'll have the ability to still provide resources to fail over and still provide connectivity in that aspect as well. So it's not just only redundancy on the leaf switch layer, but also redundancy of multiple links to the core switch as well from those leaf switches. Because you only have one or two links going up to the core switch, and you have multiple core switches, a compromise on that link can also compromise data access to your Lustre storage system. So redundancy on over aspect of the fabric side is also critical as well, to really reduce any cable issues, driver issues, and even redundancy on the failure side as well. But in most essence, the fabric is one of the most reliable aspects of a Lustre storage solution from all the cases that we've seen. And having redundancy on the storage side could be one way to reduce a failover on that. But in most essence, the fabric is not the one that causes the failover. It's all the other aspects around the storage solution that needs to be looked at and monitored to look at for a failover event. So, but this is one area that could be problematic if you have single links or a single switch to connect all your storage solution. One of the other aspects as well is the use of UPS and redundant power grid. So if on a rack configuration, most storage enclosures have redundant power supplies and redundant fan trays. But having those redundant power supplies go to one power grid also could compromise the availability of a Lustre storage solution if your power grid, for some catastrophic reasons in a data center, has a power glitch or just goes down altogether. So having redundancy on the rack PDUs and then redundancy on the power grids also increases availability for a Lustre storage solution. And in some cases, depending on where you are in the world, having thunderstorms or just power glitches for short interrupts of 5 seconds or 10 seconds, without having the use of a UPS or battery to protect your data, could also compromise data integrity for in-flight data or data that still needs to be destaged to disk, or even just having reduction of your MTBF disk drive availability as well. So having a UPS to really survive against these minor power glitches, or the ability to provide enough battery life to shut down Lustre cleanly, could also protect against other issues like data integrity or data loss in that respect as well. The final aspect I'll cover is to really increase the reliability of an overall Lustre storage solution is the tight integration between hardware, software, and the overall management layer to detect failures in overall solution. Having third-party components, having servers from one vendor, stores from another, SaaS HBAs, and trying to integrate this in a site, at a customer site, and actually keep all the firmware consistent could compromise the availability if you have different levels of firmware running on all aspects of your configuration. But having the tight integration and control aspect of the same levels of firmware, the same level of the operating system, the same level of tuning, testing integration before it arrives at a customer site also increases the reliability of a storage system. Thank you.